Brian Krebs' comment about the opportunity of cloud security for employment opportunities and the importance of it, we would get the vast majority of people back in. But at any rate, I appreciate your time today. I'll go over a couple things. So Brian commented on a very important concept about security. Right? Security is a people, processes, and technology problem. Right? It is a business problem. So while I may be talking about a lot of the technology aspects of AWS today, because we're a tech vendor, we also acknowledge the importance of people and processes, right? The cloud, there's a lot of similarities between the cloud and your on-prem data centers, but there's a lot of differences. And unlike other products, so if you switch from, say, a Cisco firewall to a Palo Alto firewall, there are some differences with the interface, but most of the capabilities are the same. And you just have to learn some minor differences. But as you do shift from an on-prem to the cloud, it is a vast difference of technology platforms that you have to learn. So what Brian talked about for training, for people, is ultimately important. So I'm going to talk about some great things we have at AWS, but I don't want to oversimplify the fact that it is still difficult if you don't have trained and capable people, okay? If you don't have a culture. If you have not shifted from that waterfall method of development with a separate operational model team to DevOps, right? Just because you purchase Jira, which is a great product, doesn't mean you have DevOps, right? It's not until you get the culture and you actually get the processes in place. So with that, I'm going to go ahead and get started. A little bit about myself. So prior to AWS, I was in the US Navy for 25 years. I managed your traditional data centers, your traditional networks. So I was the operations officer for all Navy networks and telecommunications in Europe. I was a Navy CIO for Japan and the regional CISO for Asia. When I left the Navy, I went to the city of Washington, D.C., where I was the deputy CISO for the city government, with a strategic focus on governance, risk, and compliance. Coming from that traditional on-prem environment for my entire career, my entire adult life, and I got to D.C., DC was starting to move to the cloud, okay? We were starting to implement Office 365. We were implementing the DC Healthcare Exchange, which was our implementation of the Affordable Care Act in the US on AWS. Now, I will tell you, I was absolutely terrified of the cloud. I was not going to support it. I was going to lose visibility. I was going to lose control. In a city government, and especially in the US, which is highly regulated, I had so many different compliance frameworks that I had to comply with at different agencies around the city. All right? Completely not going to support it. Completely against it. But I also always prided myself on not being the security department of no. And I'm like, if I'm going to say no, I needed to have the data to back it up. I need to be able to explain why no was the right call. So I tasked my staff, I tasked myself to just learn what this cloud was. Because to be honest, coming from that traditional on-prem environment, other than using my personal Dropbox, I didn't really have a good understanding what cloud really is. And even today, I still find that a lot of people really don't understand what the cloud really is, okay? First of all, there's a lot of difference between an infrastructure cloud service provider, which is what we primarily are, and software as a service providers. There's a vast difference in that. There's a lot of misinformation out there. We have a lot of vendors slapping the cloud sticker on their products to get in on that market share. So once we started realizing, we started digging deep on what the cloud was, it didn't take us long to figure out, okay, we could achieve the same security and compliance in the cloud. Now that was a surprise. We didn't expect that, but that was the best we could hope for. But as we kept learning and kept kind of toying around with the cloud, we started realizing a couple things, that we were actually able to improve our security and compliance in the cloud. And that was completely surprising to us, right? What it did, though, was it highlighted a couple of areas that have been long-term deficiencies or problems within an on-prem environment. That I think everybody has something in their life where you just get used to the way things are, right? Even though you know they're not as good as they should be, you just get used to them, and you just keep trucking, doing the best you can, right? And so what that did was it highlighted 4 areas that are usually problematic in on-prem environment. A lack of visibility, a lack of resiliency, challenges with implementing Defenseindepth, and then a low degree of automation. Well, I'm going to talk about each 4 of these today, and these all 4 challenges in on-prem environment actually became benefits of using the cloud. But before I do that, kind of going back to Brian Krebs, I'm going to talk about our shared responsibility model, because Brian brought up a very good point. We typically have, for brand new people, kind of really new to the cloud, there's kind of 2 trains of thought. There's either A, the cloud is not secure, I can't trust the cloud, I can't use the cloud, which is not true. Or the cloud is 100% secure. I trust Amazon, right? I shop with them every day. Perfect, which is also not necessarily true. You have a responsibility. And so, kind of like what Brian was talking about, if you build a data center today, are you disappointed that it didn't come with a firewall? No, you have to buy the firewall, right? So we have services. Some services are free. Some services are you pay for, but it's a pay-as-you-go model. So now instead of paying millions of dollars up front to build your data center, to buy your firewalls and your IDSs, you can implement what you need, test them out, use them. If you don't need them, if you find something better, you can turn it off. You didn't spend a lot of money for that. But the bottom line is we are responsible for the security of the cloud, the infrastructure, our services. Our customers are responsible for the security, oh, their laser's hitting over there, in the cloud, okay? So we have services, encryption services. It's up to you to actually use them. Really not, there are moments in time where not every piece of data must be encrypted. If you have a public-facing web page with public data, right, you want that secure HTTPS, right, but the public data itself may not need to be encrypted. You have a cat video, that doesn't necessarily need to be encrypted, right? So it's up to you to turn on those services and use them as you need to meet your business. All right, so from there, I'm going to get into the first point, the first benefit, visibility. This is boring stuff. This is like what Brian was talking about, the boring basics. I call it cyber hygiene, okay? But the important thing about visibility is that you cannot secure, monitor, or respond to anything that you don't know exists. Visibility in an on-prem environment is very challenging for a variety of reasons. I've had many of these happen to me in my experience. Everything from, you have all these different technology platforms. They all have different logging schemas, right? The information that they track, how they're organized, how they're used, okay? They might have different timing sources, hopefully not, but oftentimes on a network, they have different timing sources. So as you're trying to correlate activity across different technology platforms, it can be very difficult to correlate that. Now, we have some great SIMs out there that try to help with this, but it can still be challenging if you have different timing sources. Network segmentation can also be a problem. Oftentimes, not all of the logs get from one part of the network to where your SIM is, right? They're being blocked for some reason. Your security tools may not be able to get through a network segment to scan what's in there. You might have endpoints that aren't either configured properly or reporting properly. Okay, there's a variety of reasons why we don't really get the visibility we need in an on-prem environment. And it's something that it's in our mind, in the paradigm that we have, it's kind of, it doesn't make sense, right? If I can physically touch the server, well, I have visibility into it, right? But the days of physical visibility being what's important are over. Today, you have to have logical visibility. In an on-prem environment, that's what's really challenging, is that logical visibility. So I'm going to kind of go through, because visibility is kind of the boring basics. I'm going to make a few points, but I'm going to try to go through these a little bit quicker so you get some more exciting stuff. So in AWS, there's a couple ways to obtain visibility, but we have our general console where you can log in and you can see everything you have. So this changes a little bit, right? So now it doesn't matter whether the status of the server is on or off, what network segment it's on, what part of the organization owns it. If it's in AWS, you have that visibility that you know it's there. You know its state, okay? One of the most important things is to be able to use resource tags, right? So oftentimes in an on-prem environment, it's difficult to identify network assets unless they're named a certain way, right? So in my experience, we used to name our Microsoft Exchange servers for email EXCH01 or 02, right? So that way when I look at it, oh, that's an Exchange server, right? Well, now you can tag all of your assets. and use more than one tag. You don't have to rely on a particular naming scheme. So now I can tag a set of servers or some assets with a particular department code, a particular compliance. So if everything needs to be PCI compliant, I can tag them all as PCI. Now when I run queries, I can run a query, give me all the assets that must be PCI compliant, okay? So now I'm able to add some context with some of the visibility of the assets I have, which we typically didn't have before, okay? Skipping to probably the most important thing, though, is the ability to use API, right? So as we continue to grow, as our IT infrastructures continue to grow and scale, we cannot keep up, right, through human manual processes, okay? You've got to be able to automate. And the way to automate is through APIs. Every service within AWS is operated off an API. So even if you're in a web console, clicking on a link, it gets converted to an API. That's how our services talk to each other. That's how our services talk to other products from our partners. And so API-driven communications and visibility is the key here. All right, so again, in the respectful of time, I'm not going to go into all the services, but I want to highlight a couple of differences here. So these are just some of the services that provide visibility, primarily for security purposes. Every service provides information about how you use that service, but these are really what we typically see in a security environment. So what I want to highlight here is this AWS Cloud Trail. This is the fundamental logging service for all the activity within your environment, right? You no longer have to worry about different schemas from different product vendors. You don't have to worry about different timing sources or network segmentation. Because we have the homogeneous infrastructure underlining everything, we have that visibility, that improved visibility for all the logs that are there. This tracks all the activity within your environment, okay? Who did what, when they did it, was it a service account, was it a user account, what role were they using? Absolutely everything within your environment for activity, okay? The Amazon VPC flow logs, that's all that network traffic coming in and out of your AWS environment, okay, that you have sitting on top of our infrastructure. CloudWatch is basically, I don't want to really call it a SIEM, all right, so there's some very powerful SIEMs out there, but it really aggregates those logs into one central repository, and you can create alerts and events on it. Okay, so so far this is kind of basic stuff for you, right? You have this in an on-prem environment, although I would argue that the improved reliability of those logs are better here. But CloudWatch, based off those alerts and events, is fundamental to probably the greatest, well, one of the greatest advantages of moving to the cloud, and that's the ability to automate, right? So I'm going to talk more about automation later. But then we start getting into services like AWS Trusted Advisor. So this is a free service. What you're able to do now, Trusted Advisor looks at your environment, and it helps you determine if you are following best practices, right? Now, in an on-prem environment, if you wanted to know if you're following a best practice for a particular product, you're going to have to download the best practice guide and do a manual comparison, right? Who's done that, right? Hopefully the engineer, when they first installed it, did it, but who knows what changes over time. Trusted Advisor is always looking at your environment. Are you always following best practices? Are you using multi-factor authentication for your root and privilege accounts? Do you have an S3 bucket? S3 is our simple storage service, right? So that's where you can store all your files. By default, it's not open to the public internet, okay? From an organizational perspective, there are controls you can put in place that would prevent S3 from ever being open to the public internet. However, some customers still, unfortunately, make a mistake, and they do open up a bucket to the internet that has sensitive information in it. That's usually what you see in the news when you see our name. Trusted Advisor lets you know when you have a bucket open to the public internet. Right? Not to mention that you have to click like 100 warnings when you try to do it to make sure you know what you're doing. But the point here is you have these services now, because of the homogeneous environment, to start looking at your environment. Doesn't just give you the visibility, you're able to automate that visibility and let you know when you're not necessarily following best practice. I'm going to talk more about GuardDuty later, but between GuardDuty and Macy, Macy is a service that looks at your files, your storage, and it lets you know where you have sensitive data at rest. So when you think of the traditional data loss prevention or DLP service, right, it typically sits at the perimeter, and it's looking at sensitive data trying to leave your network. right? And it either blocks it or it allows it and it alerts you, okay? But where is that data to begin with? Have you properly secured the data to begin with? That's usually the challenge. So Macy will help you identify where your sensitive data is at rest. So you can take actions on it to properly encrypt it, properly manage access to it before anybody ever tries to access it or allow it to leave the network. Also, between those two services of GuardDuty and Macy, it has some user behavior analytics. Right? So Brian was talking about this earlier too. If you have, say, an Excel file with all your employees' sensitive data on it, their addresses, their phone numbers, maybe even Social Security, well, I think it's called SIN here, right? It's accessed by 2 people in HR, Monday through Friday, normal working hours, right? It learns that. Well, what happens if that file is accessed over 500 times at 2 o'clock in the morning on a weekend, right? It detects that anomaly, that user anomaly, all right? So these are the things that start providing that visibility, all right? So now this is fundamental. So while visibility is boring, it is part of cyber hygiene. And you cannot get to the advanced stuff. You cannot really stay on top of your security unless you have solid visibility to begin with. Actually, I should step back. So AWS Artifact is not a real IT service. It's a document repository for all of our third-party audit reports. So we comply with over 90 different framework standards, compliance regimes internationally. And so if you want to pull down an audit report as a customer and look through the controls that were assessed and how well we did, you can do so through AWS Artifact. And while it's not up here, I don't know how many people know, I am pleased to announce that as about a month ago it was released that we meet the protected B medium standard at the Canada national level, so PBMM, okay? And we also are compliant with BC FOIPA. All right, so with that, we're going to get into resiliency. This is one of my favorite aspects of the cloud. This is one of the things that really started opening my eyes to the true benefit of the cloud. In security, we talk about CIA, right? Confidentiality, integrity, and availability. However, we focus most of our efforts on confidentiality and integrity. Availability is hard, right? I heard in the KPMG session, when it was talked about resiliency, the words used after that was disaster recovery, right? Okay, well, let's start, because high availability, having something in place to prevent the disaster or to overcome the disaster as it happens without having to go to your DR plan is actually more important. This is one of the reasons why, even if costs were the same, this was to me, one of the greatest advantages. Actually, we step back. My time in the Navy and my time in DC, probably the thing that I worried about most, and it was actually brought up by the CEO of Econ 11 last night in the reception panel, was a denial of service. What happens if you're in a city, like when I was in DC or here in Vancouver, if 911 goes down, right? Or somebody does a denial of service of that, okay? Even some of the most critical applications for some of the largest organizations that spend a lot of money, typically those critical applications live in one physical data center, oftentimes on one single server stack, right? And I can't tell you the number of times that I've had to worry about if we lost a server, it's hours or days before we get it reconstituted. Or if we lost a data center, having to reconstitute another data center, okay? Some people have the money, they might have a cold site, but it's still hours or days before they bring it up, depending on the data. So with AWS, you start getting a resilient, highly available infrastructure to build on, and this is what's important. So we have 22 regions, 69 availability zones, and 199 edge locations. So you can see the cities where we have the regions, and the number of parentheses are the availability zones. Okay, so this is very, very important to understand as to what the infrastructure is. So what is a region? So this can be kind of confusing, because even though we have several infrastructure cloud service providers, and we all use the word region, what region means differs between us, okay? And so it's very important to understand this. So a region for AWS is a metropolitan area, okay, where we build our data centers within a particular country, okay? A region is comprised of at least 2 or more availability zones. Now, the new standard is 3 availability zones, so that's what you're seeing now. Some availability zones, like in US East, has 6 availability zones. An availability zone is a logical concept. It's a logical fault isolation zone, okay? This is how we build our infrastructure that allows for us to do maintenance and limit the impact and scope of any type of service outage. Within an availability zone is at least 1 physical data center, but there are typically more, okay? We do not disclose a number or locations of data centers for security purposes. But this is where the differences lie between cloud service providers, okay? An availability zone for us, because we have these physical data centers, our data centers are physically separate facilities. They are not data center 1 on the first floor, data center 2 on the second floor of the same building. What good is that if you lose the building, okay? So, and of course we have the typical, multiple ISP, multiple power generators and so forth coming in. But the availability zone concept is what allows us to provide, for the vast majority of our services, an SLA of 99.99% for availability and a durability of our S3 storage of 11 nines. That's 99.9 more 9% durability, okay? That goes into what's the risk of us losing one of your files. And I forget the total number, but it's something like we might lose 1 in a billion files over 1 million years, okay? This is really important to understand this, okay? So from here though, so it's great. We have this, good for you, AWS. What does it mean for me? Well, this is where you can start to build on that infrastructure. So this is, say, a typical on-prem data center. The firewall at the top is just your typical perimeter security, whatever it may be. Okay, you have load balancers. These are physical appliances, right? Hopefully you have more than one. But you still get into a situation where you could potentially, depending on, maybe you bought them 4 years ago and you're already at capacity. If you were to lose one of your 2 load balancers, you might not be able to service all your customers if you've grown over the years, right? It comes to that lifecycle management problem again for an on-prem environment. You have your web servers, your app servers, and a database servers, and a 3-tier web app model. In this particular case, depending on your model, if you lose one of the app servers, your load balancer may not know that, right? Still going to send traffic down that web server, and those customers are going to start getting timed out. They're not going to get serviced, right? But at any point, there's several single points of failure from the physical data center, the perimeter, and so forth that can be challenged. As you start moving to AWS, you select the region that you want to operate in. When you select an AWS region, your data stays in that region. We do not move, copy, or back up your data into any other region for any reason, okay? So if you have any type of national or any type of data residency requirements, you can meet that within AWS. Now, I will say there's one caveat to that, and that's our artificial intelligence and machine learning services, okay? We do have, in our service terms, a statement about us having the ability to use that to improve our models. However, you can opt out of that, all right? So I want to let you know that there's that one grouping that does say that, but you can opt out, okay? So you can rest assured that your data stays in the regions that you choose, okay? You're going to select, you're going to create a VPC, a virtual private cloud. This is the security boundary around your application. So before an on-prem, you have a security boundary around your entire network. Everything stays within that, right? Now you're going to have a security boundary around each application. You're going to select at least 2 availability zones. I highly recommend selecting at least three. So anybody who's done risk management, risk calculations, you know the power of n+1, you're going to know why you want at least 3. Okay. So from there, you're going to create your subnets. But this is where things start to change a little bit more too, is instead of having these physical load balancing appliances, you now have an elastic load balancing service, okay? We have load balancers that operate at the network level or at the application level, so depending on where you want to operate an ISO model, okay? Also, because they're not these expensive physical appliances you buy once, you can afford to put them at various tiers, and actually I should have had one there at the bottom tier. I think that graphic went away on me. So now, as you have the servers, if you have this app server over here fail, the load balancer here will automatically detect that and send all the traffic over. All right, so now you have resiliency built in, high availability built into your application. Okay, if any of the servers fail, it'll move over. As we add the auto-scaling group, the auto-scaling group does two things. So the first concept is the ability to scale out when you need to and scale back in when you don't need the resources. Okay. So for example, pretend that you are a university. You have a course registration application that 3 times a year, thousands of students hit to register for courses for the next semester. Most of the year, they're sitting pretty idle. The college admin staff will update the professors, the terms, dates, so forth, right? But you have to buy these very large, expensive servers on the left, okay, that sit there most of the year. You're wasting money, you're wasting capacity. And then you're going to have to replace them every 3 to 5 years, right? On the right, you will go from these very large servers to very small servers, one in each availability zone, just enough to keep the lights on, okay? Just enough for the admin staff to do their normal work. As soon as course registration season opens, whether you set a particular day and time or you have a threshold when maybe it's a CPU usage and RAM usage, when the auto-scaling group and the load balancers notice you hit a particular threshold, it automatically starts scaling out servers to handle the load. You can designate a minimum and a maximum number of servers. Okay? Course registration ends, the servers go back down. So this is where you start saving money. Apologize for that. Within AWS, right? Before, if you wanted high availability, you are going to spend an absolute fortune on multiple data centers, lots of duplicate hardware, especially the networking and routing between them, and so forth, right? The other thing this does is, when you go back to this model here, this provides for a self-healing architecture, all right? That's very important. So if you've ever been a sysadmin, if you know sysadmins treat their servers like pets. We feed them, we pet them, we give them names. If a server dies, we cry. It's a bad day, right? Because we know it can take hours or days to get that thing back in operational, okay? In this model here, if one of these servers was to crash, not only does a load balancer shift everything over, but you've gone below your minimum threshold of 2 servers. As soon as that failed health is detected, it automatically spins up a new server, comes online, checks in healthy, load balancer redistributes back. You've replaced that server within a couple of minutes, right? So depending on if you're using Linux or Windows and what you put on top of them, the times can vary a little bit. But within a few minutes, that server is back and operational. No impact to customers. The sysadmin, other than getting the little notice, is like, oh, that's nice, great, go on with my day, right? Doesn't matter anymore. Right? So this does take some re-architecting of your applications. We can't have those very monolithic applications with all your data on that server. Right? We want to start decoupling our applications and our services. Right? That's very important here. Okay? And then our data centers also within the region, they're close enough and they have the bandwidth to support synchronous data replication. Okay, so this is very important for that high availability to have synchronous data replication within your application. So if a database server was to fail, it's okay because you still have all the data in the other database, okay, in that region. Now obviously because of geographical distances, anything outside the region or region-to-region replication can only be asynchronous, okay? And so while you can achieve, in many organizations, you can achieve your resiliency requirements within a region. For those who still need more, you can have your disaster recovery strategy to use a second region. Or if you're more of a global, to actually have multi-region infrastructure. All right. So last point on this is this allows you to shift from a reactive disaster recovery risk model to a proactive resiliency risk model. Right? Not that you're going to get risk down to 0, that's never the case, but you're able to mitigate the vast majority up front instead of just having a plan place in the end, right? So this also goes to like what Brian was talking about today, that reactive. You know, we were talking about how everybody spends all their money on the protective measures and not so much on the reactive measures. This right here is where you have that built-in reactive security controls in place. All right, so moving along to Defenseindepth. So this has been a term for decades, right? As long as I've been in the military, we had this term. And I think there's some old either late 80s or early 90s publications that talk about this. Unfortunately, this is the reality, right? We focus all of our protections at the perimeter, layer upon layer upon layer at the perimeter. And then we put an endpoint protection, right? Everything inside is soft and gooey. In most of the data centers I've been in, either that I owned, that I hate to say, or other colleagues of mine, everything within data center can talk to everything, right? Sure, we have some network segmentation, but that's usually for network traffic flow management, not so much for security. That's a side benefit, right? But we have applications and servers in a data center that should never talk to each other, but they can. This is why phishing emails are so successful, because it's an open trust model. Once you're in, right? And once you're in, you can float around, you can get to where you need to go to, okay? So what we need to do, the Defenseindepth kind of term is starting to go away. Like a lot of things in security, there's these great concepts that just never get implemented properly, and so they become, they have a bad reputation. It's a perfectly valid concept, we just never implemented it, right? So as we shift from the term Defenseindepth to zero trust model, this is where it starts looking like in AWS. I'm going to go a little fast here. The perimeter is still kind of similar, right? We still have your security boundary, you still have your subnets, you have your access control list that provide kind of a stateless type firewall capability within your subnets. So real quick, this particular diagram right here, this application that you have, at this point in time, nobody can get to it. It is not open to the public internet, all right? So unless you log into the console, the AWS console, to manage those assets, nobody can actually use this application, okay? In order to do so, you can add private fiber between your VPC and your data center. So if this is, say, an internal application for your company, it's not something that's ever going to be made on the public internet. You have that private fiber between us and you, so then you can access it. You can add a VPN gateway, so you can VPN from anywhere with the right credentials. If you do need it to be added to the public internet, you add an internet gateway. At this point in time, if everything's configured properly, the web servers can get to the internet, right? Or the internet can get to the web servers, right? Very similar to an on-prem, right? You have, through your firewall, you have a means to get out, right? On port 80 and so forth. By default, everybody gets DDoS protection for free, okay? So right now you're paying somebody for DDoS protection in an on-prem environment. Now you get it for free. Now this is for Shield Basic. We have Shield Advanced that you can pay for. You get a timed SLA response from humans and some cost protections and so forth. We have our own web application firewall, but we also have the largest ecosystem of security partners. So whatever you're using today, you most likely can use inside of AWS. So you can still have that single pane of glass, and you can see what's on-prem and what's in AWS, and you still manage them the same way. And then, of course, GuardDuty, which I'm going to talk about more later, again, but it's our intelligent threat detection service. So right now, the perimeter is still fairly similar. What starts changing is, by default, your applications no longer can communicate, okay? If for some reason one application within your organization is compromised, they can't spread to the others by default, okay? Now you can add in the ability for them to communicate if those applications need to. So you have, if they want to talk at the application layer, you can add in the internet gateway and have a VPN connection. We have Private Link, which is a private secure communications really for those microservices, those decoupled applications. And then we have VPC peering that can bridge them over the network. We have a newer service that I don't have up here called Transit Gateway. This is really beneficial in the security area. So you can have all your VPCs for all your different applications that you have in AWS, all the traffic go through a central transit gateway. So if you have a particular security stack, you don't have to necessarily implement the same security stack in every single VPC. You can implement it in one, and all the traffic from all the other applications go through the transit gateway, and then out through the one security VPC. Then we start getting to a little bit more down the stack. So we have what we call the security groups. A security group is a stateful firewall capability at the instance level. So this is kind of a host-based firewall, okay? But it's not an agent. It doesn't sit on the host. Your server doesn't have to be up and operational, right? So what's one of the challenges with a host-based firewall? You know, there's still a moment in time when it's booting up and everything's coming online when the firewall's not up and operational, right? This sits outside of that, okay? So now you have the stateful firewall capability between the tiers. Before, if you wanted, it was very difficult to implement a firewall capability within an application, right? We already talked about how even different applications are open. So now you have that firewall capability, stateful and stateless, between the tiers of the same application. By default, servers within the same security group cannot talk to each other, right? One web server should never talk to another web server. Should be talking only to the app server down the database, and back up the line, right? If any server is talking to any other server outside of that, it's been compromised and they're trying to lat move. They're going to go straight after the data if they hit the web server, or they're going to try to maybe find out what else they can talk to. So by default, you don't have communications between applications, you don't have communications between tiers of the application, and you don't have communications between servers of the same application. We go back to that privacy by design, security by default. This is it. Now you start having where nothing's open unless you explicitly open it, okay? You can still add whatever third-party endpoint protection you want onto your servers. We have Amazon Inspector, which is our vulnerability scanning tool, but you can still use whatever you choose, Nessus, Nexpose, whatever it may be. The advantage of Amazon Inspector is it also has a feature for network availability. In an on-prem environment, now we'll say our firewall engineers today, they're amazing. Anybody in here a firewall engineer? Right? They know their stuff, right? But what happens if a firewall engineer accidentally made a mistake when they were typing something in and they opened up a sensitive database server to the public internet? How would you know? When Brian Krebs calls you, that's when you know, right? Amazon Inspector has a feature called network availability that it will look at your environment and mathematically determine what is available to the public internet and what is not, right? So you don't need to sit there and go through all your firewall settings and look at all the IP addresses. This will tell you right off the bat what's open to the public internet, what's not, okay? We have a systems manager. So it keeps track of the inventory of all your servers. It can push patches, tells you everything. Going back to cyber hygiene, boring basics, patching. When I was in DC, I had to help lead the response for the ransomware attack on the police department's CCTVs that were around the city 2 weeks before the presidential inauguration. That was not a fun weekend. Patching, all the super exciting security stuff, if you're not patching, if you're not managing your patching, I'm sorry, AI/ML is not going to help you too much, right? So focus on patching. Oh, and not dropping your tools. So from there, I already talked about the logging capability that we have, CloudTrail, and then there's that GuardDuty again. So now I'm going to start talking about GuardDuty. Okay, so automation. So all the detection capabilities in the world are not going to protect you, right? It is absolutely fantastic to have the ability to detect user behavior anomalies, right? When somebody is accessing something they shouldn't be. It's absolutely amazing to be able to tell, okay, I'm getting attacked by this known cyber criminal or this thing here. If nobody's watching, if nobody's doing anything to act, it's useless. And the reality is, what was brought up earlier, with the shortage of talent and training, even if you do have good people, you don't have enough. They're not fast enough. So the thing here is to automate. Remove humans from the data. So in AWS, our CISO put out a requirement to remove humans from data, from being able to make mistakes by 80% year over year. Right? Now that stuff is not 80, it's not 10% one time, or even 80% one time, 80% year over year. And we're able to do that through automation. We're able to manage our global infrastructure primarily through automation. As soon as something happens within our infrastructure, something that shouldn't have happened, we identify exactly what it was, and then we implement automation to prevent it from happening again, okay? So when we start talking about, actually let me start with GuardDuty. So this is GuardDuty. It's our intelligent threat detection service. It brings in threat intel from Proofpoint, CrowdStrike, as well as threat intel that we developed from managing our global infrastructure. That threat intel adds context to the activity that GuardDuty sees within our environment, or within your environment. So everything in white are the signature-based or stateless findings or threats that it can detect, and everything in blue are the behavioral or stateful threats that it can detect, okay? So everything from command and control activity to Bitcoin mining and so forth. As we start, actually, one thing I want to bring up. So one of the things that I like to highlight here is when you stand up a web server, as soon as you stand up a web server online, it's being scanned by everybody, right? Google's scanning to add to the search engine. Script kiddies are scanning it. It was brought up earlier, we might even have a nation state scanning it, okay? How do you know what scans are more malicious, what actors are more threatening to your organization? So that threat intel provides that context to you. So GuardDuty will tell you, okay, you're getting a particular port probe scan and a brute force attack. It's coming from this IP address. This IP address is a known cyber criminal, or it might be associated with a known APT actor. It's coming from this country. It's coming from this ISP, right? So now you have some context to say, okay, I'm a little bit more worried about that one than I am the one that's coming from Google, okay? So as we start looking at that though, we start looking at the ability to automate. So GuardDuty will have that detection. It will create the event in CloudWatch. CloudWatch can trigger an AWS Lambda function. So Lambda is our serverless function service. So think of it as just little snippets of code waiting to take action based off of an event, okay? So in this particular model, I have a malicious scan coming from a known cyber criminal, coming from a known country I'm worried about. I'm gonna have a Lambda script that takes the IP address of that attacker, and I'm gonna automatically add it to my web application firewall filtering rule, right? So within a couple of seconds to a couple of minutes, I've completely blocked the scan. They can't continue to scan. If they found an exploit, a vulnerability, they can't exploit it, okay? Not only that, but I didn't just stop it from that one server, I stopped it for every server behind the WAF, okay? Now if you need to add a human in here to make a judgment call, you can add a human stop gate, okay? So you can have all the research built up and automated, your SOC analyst presented with a list of choices, add it to the WAF, add it to the next generation firewall, ignore it, you know, put it on a watch list, but you can have a human ready to make a judgment call, okay? You can also do more than just one thing. So you can do several things all at once. Two things that I highly recommend is don't just automate the mitigation, automate the notification to the right people, and also automate the update of your documentation. Security operations, we see a challenge where either A, security operators don't have the ability to actually make changes on the network. They have to reach out to somebody else and say, hey, I see this going on. Can you block this port? Can you do this? Right, which takes time, right? When we do see security operators have the ability to make changes, oftentimes those changes are not reflected in the configuration change management database, right? So then you start losing your source of truth. So automate the mitigation, automate the notification, and automate the documentation of your infrastructure. So we have a lot of different security services. I'm not going to go into all of these. I talked about some of them already. I will say we have a saying in AWS that you can move fast and stay secure. And that's true, but I will caveat that it's only true if you spend some time in the beginning to get your governance model down. Right? Focus on what's your governance strategy, put in the guardrails. So when Brian Krebs was talking about cloud security is hard, it's hard for two reasons, or a couple of reasons. One is there's a lot of things new about it, right? It's not just a couple of small changes from a platform you're used to an updated platform. It's an entire change of your infrastructure and everything in it, okay? That makes it hard. It's hard because a lot of times organizations want to move, they're in a rush to move to save money. and they don't apply the same governance strategy or a programmatic model to it, all right? So it's still part of your IT portfolio, right? You should still be approaching cloud in a programmatic way. You should still be looking at your governance strategy, but you got to build the guardrails. What's different is you don't have to go to that yes, no checklist. You don't have to lock things down. Nothing in IT should ever be locked down. Locked down means it's not usable, right? We are here to support the business. We should have guardrails in place to keep whoever wants to go as fast as they want to go, the ability to do so, but safely. Lastly, if you are considering moving to the cloud, I know it can be a challenge. Actually, I think pretty much everybody here is in the security role, but for those who are not in a security role, make sure the security team is brought in from the very beginning. I don't care if you're just putting your public-facing, non-sensitive website up into AWS or the cloud. Make sure security is there from the beginning, that they understand what's going on. They have time to learn about AWS. They have time to learn how to monitor what's in AWS and respond to it. So by the time you get to mission-critical applications, the security team is ready. Because if you don't, the security team is going to be a blocker as soon as you get to that level. I always thought this was a pretty powerful quote, right? Everybody knows NASA. We're talking literal rocket scientists, and they have lots of money, and they felt we could do security better than what they could do on-prem. And so in my own personal journey, I found out that the cloud was not just as secure, but it can be more secure, and I can have greater confidence in my compliance. What that translated for me was going from fearful of the cloud, completely trying to block projects that are moving to the cloud, to where security took an active leadership role in the development of the city's cloud adoption strategy, right? So I think that was very powerful. When you have security coming aboard and driving something like that, it's very important. And so with that, come visit us at our booth. We're upstairs. You can register to win an Alexa. My graphic is not popping up. There we go. Drop off your card, Alexa. I think I'm going to be out of time for questions, but if you want to go up to the booth, I'll be happy to take any questions up there. Thank you so much. If you want the slides, come up either now or later, and I'll give you my business card. I'll be happy to send them to you.